Niels Bohr modified Rutherford's nuclear atom model to explain how light interacted with the electrons in an atom to produce spectral lines. His model includes electrons orbiting the nucleus at specific energy levels. Electrons absorb energy from various sources, like electricity or heat. When they move from lower energy levels, the ground state, to higher energy levels, the excited state, energy is released as electrons return to their lower energy levels. Okay, so when we read it again, let's add in our annotations. Niels Bohr modified Rutherford's nuclear atom model to explain how light interacted with the electrons in an atom to produce spectral lines. Okay, so spectral lines are unique patterns that are created by each element when we view them through a spectroscope. We're going to be looking through spectroscopes soon. These are as unique as fingerprints, kind of like density, and we can use these spectral lines to help us identify what element we're looking at. In fact, spectral patterns are the reason why we know what the sun is made out of and stars are made out of. His model includes electrons orbiting the nucleus at specific energy levels. Okay, so I know that electrons technically don't orbit. They occupy spaces called orbitals. We're familiar with the S, P, and D-shaped orbitals. There is the F orbital, but we don't worry about that in this class. We also know that electrons do occupy specific energy levels. So Niels Bohr was half right. We do have specific energy levels. They just don't orbit the nucleus. They are in orbitals. Electrons absorb energy from various sources like heat or electricity. I didn't add an annotation for this, but it might be something to note because that is what we're using in our flame test lab later on this week. When they move from lower energy level, the ground state, to higher energy level, excited state. Okay, so I'm going to just chop that sentence down a little bit. When we absorb energy, we go from lower energy level to higher energy level. Great. Energy is released as electrons return to their lower energy levels. I actually like that whole sentence. It says, consider the model of the atom provided to the right. This model shows an electron moving from quantum level 2 to quantum level 5. Based on this information, answer the following questions. Okay, so if we're going from 2 to 5, energy is going to be absorbed because that's what it says here. If we go from lower to higher, we are absorbing energy. We're taking in energy. And I actually like to show that by using either a squiggly arrow pointing into the atom, or you can use a lightning bolt with the tip pointing in, showing that energy is going into the atom, and the atom uses it to push that electron up. Now we're going to justify that answer by using the word quantum. Remember that quantum is the amount of energy that's needed to push an electron into a higher energy level. So my justification would be, when a quantum of energy is absorbed by an atom, electrons use that energy to jump up to higher energy levels. So we know that when a quantum of energy is absorbed, the electron is going to increase its energy level. So here we have a Bohr model of the atom with just one electron and one proton, hydrogen. We can see that we are on quantum level 1. Now, if I wanted to put energy into this atom, it could be in the form of electricity or heat, like in our flame test lab. We're not burning it, we're just heating it up really hot. When we do that, the atom uses that energy to push that electron up into a higher energy level. When that electron is in a higher energy level where it's not supposed to be normally, we call this the excited state. Now, when that electron's up in the excited state right now, it's not going to be able to stay up there forever. In fact, it actually needs to fall back down to its original state eventually, and it happens pretty quick. When it falls back or relaxes, a quantum of energy is going to be released. So you can see the little lightning bolt heading outwards. When it falls and it relaxes and it releases that energy, that is when we see the release of energy in the form of colored light. And we see this during the flame test lab we're going to be doing later. So now that it's fallen back down to the original energy level, 1, the atom is now technically back in its ground state. So if we look here, I've got two orbital diagrams of carbon. One on the left shows carbon in its excited state. We know that this is true because this electron up here in the third energy level shouldn't be here. It should actually still be in the second energy level. The Aufbau principle tells us that we need to fill the whole energy level before we can move up to the next energy level. But again, this was probably an atom that was subjected to some energy. It absorbed that energy and used it to push that electron up into a higher energy level temporarily, which is why it's called the excited state. Eventually, that electron is going to jump back down or fall back down. It's going to release that energy, and then it's back into its normal electron configuration, which is called the ground state. We can see that represented here with the Bohr atomic model. We can see on the left, the excited state, that atom or that electron is in a higher energy level than it's supposed to be. This is exciting. It's new. This is the excited state. When it's back in energy level 1, that's its normal electron configuration, and so it's called the ground state. So some summary questions you might want to jot down, really great review. If an electron moves from n equals 2 to n equals 4, energy is what? Energy is absorbed. Remember, it takes energy to push that electron up to a higher energy level. If an electron moves from n equals 4 to n equals 3, energy is emitted. It's released. When we fall back down, we are releasing energy, and we can actually see that energy being released in the flame test lab in the form of colored light. And then, which transition will emit the most energy? Quantum 5 to quantum 2 or quantum 5 to quantum 3? The larger the jump, the more energy that's required to either absorb and push it up, or the more energy will be released. So now, if you turn the page, you'll notice that you have 4 atoms labeled A through D. And then each of those atoms have 4 little fill-in-the-blank statements, and at the top of the page, it tells you what you are doing for each of those statements. So for A, you're going to label each picture with the quantum numbers that we jump to. So here we're starting at quantum number 6 and jumping all the way down to quantum number 2. Letter B, we are then explaining if the electron moves from a high or low energy to a high or low energy. So electron moves from low to high or high to low energy. Letter C, if the electron transition absorbs or releases energy. And then letter D, if light is absorbed or emitted in the electron transition. And that's what you're filling in for A, B, C, and D, these 4 statements underneath each of those atoms. Okay, now it's your turn to practice. Good luck.